Hi students, welcome to our channel. Today we are going to discuss about graph coloring. This is one of the topic in our backtracking. Now we are going to discuss how we are going to solve that using backtracking. Before going to that, let us see the definition of graph coloring. What is meant by graph coloring? In any given graph, G is equal to V, E, the two undirected graph, we should color the vertices in such a way that no two adjacent vertices have same color. Okay, we will color the graph in such a way that no two adjacent vertices are in same color. That is our graph coloring. Now first, how we are going to say, we'll check the possibilities without using the method, then we'll go for actual method. A, B, C, D. This is given graph. Okay. In this given graph, we have to color our given usually given colors of RGB, that is primary colors, RGB. Now for A, if suppose we are giving R, we are not supposed to give R for both B and C, since they are adjacent, B and D, since they are adjacent vertices. Now we can give same R here. Okay. Next, here you can't give R. Here you can't give R, and now you can give green here. And even B also, you can give B also here. Different possibilities are possible, right? You can give green here, you can give blue here. Different possibilities are possible. I mean, different solutions are possible. Now, whichever it is giving solution, we are going to find that as feasible solutions, and we'll find out all possibilities and find out from the possibilities we are going to derive the feasible solutions using backtracking. That is your graph coloring problem in your backtracking. Okay, fine. Now we will go to the actual problem, that is graph coloring in backtracking. I hope you understood this introduction about graph coloring. This is the given graph. I hope it's visible. This is the given graph. We are going to derive the solution using state space T. State space T. State space T. A state space graph. How we are going to derive the solution? Now, since we are going to start everything from root. Okay. Now, for A, suppose we are going to draw for A. First we will see this about A, then we'll go for rest of the vertices. For possibilities for A, x1 is equal to R. This is one possibility for A. Next, possibilities for again GB, even green and blue also may be possible to color, that is first vertex. I mean first time with A. Initially we have colored A with color red. That is our concept. Now we are going to check different possibilities from A. Okay. Since it is backtracking, we have to go for depth first search. Okay, we have to go for depth first search. Now we are going to look about depth first search, how we are going to use that. Now we have colored A with red color. If it is possible, I would have used that red color marker. I hope you understand, since it is red. Okay. Now here you have possibilities. If you are going to B, now you are going to B. When you are going to B, you have three possibilities. X1, since x1 is completed, x2 is equal to R. But this is wrong. Okay. So what you should do? You should backtrack. Now B node, x2 is equal to green. Is that okay? It's fine. So this is the feasible solution only. Next we can continue the solution. It's not, a rule is not violating. Now C. Now C, since C is here, x3 is equal to red. Is that possible? Since you have C here, now here it is R, here it is green. Here if you are keeping red, it's fine. That's why it's possible only. Next, since you are telling that it is depth first search, you should go to the next node also. D. x4 is equal to red. Is that true? You can't keep this as red, isn't it? This is wrong. Now we are going to backtrack this one. Okay, now you are going to backtrack. What you are doing now? We'll go to C and D here. x4 is equal to green. This is G now. It's accepted since there are no adjacent vertices. Now this is one feasible solution. That is red, A, B, C, D. Red, you are starting with red, then green, then again red, then again green. This is one solution. Now after this, if you are finding a feasible solution, then also you need to backtrack until finding all possible solutions. That is the main thing about backtracking. Now D. x4 is equal to blue. This is also accepted, right? Since no two adjacent colors are given same color. Now R, G, R, B. This is also solution only. Are you getting? Now you have got two solutions when you have taking node A with red color. Okay. Now we will go for backtracking. Here you have stopped here with C. Now you have to go here. When B is equal to green, you have stopped. Now you have to backtrack. B. I hope it's visible and I am teaching it out aloud also. B. Now x2 is equal to B. Okay. So now it is blue. Understand? Now C. We'll write little bit wider so that it will be easy for you. Here it is B. We'll think like that. This is one solution space we have already. Now it is B. x2 is equal to now blue. x2 is equal to B. Now you have made it blue. Now C. Coming to C. x3 is equal to red. Is that accepted? You can check now. Yes, it is accepted. No two colors are getting same color. So next, coming to D, x4 is equal to red. If you are writing red here, you are getting two adjacent colors as red. So it's not possible. Okay. So we'll kill this node here. This is not possible. You can backtrack. Now x4 is equal to green. Check once. x4 is equal to green. That is D. You are having green here. Is that acceptable? If you are having green, yes, it is acceptable. So you can write this as one solution. That is red, blue, red, again green. This is also acceptable. Next, you have when you are coming out, you have one more possibility. That is x4 is equal to blue now. Red we have covered, green, now blue. Now you can check this. This one also, if you are taking this as blue. If you are taking this as blue. Is that correct? Red, blue, red and blue. This is also feasible solution. So red, blue, red, again blue. All these are feasible solutions. Our main concept of backtracking is obtaining the feasible solutions from the given data. That is our main concept of backtracking. Now we have covered once 4 solutions using when x1 is equal to r. Since this is only one set when a is equal to red, a is colored with red color. Now we have different possibilities when A is equal to green color and when A is equal to blue color. Now we'll check that also, and since the board is not sufficient, you can refer my notes. In that I have given for all colors in same place. Now since the board is not sufficient, and even you may confuse if everything is written here. It may be little clumsy. That's why now I am going to, for when x1 is equal to blue, I am doing in separate page, but don't mind that this is the part of the solution. You don't think that is one more solution. Okay, this is the part of our solution. From root only I am starting now. Fine. Now root. Now already we have checked possibility x1 is equal to r. Means red color we have checked the possibilities. When we are coloring node A with red color, we have checked all possibilities. Now we'll go for, we'll try here only, because x1 is equal to green. Okay, x1 is equal to green means that you have colored A with green color. Okay, A with green color. Now whenever x1, that is you have colored A with green color, from A you have different possibilities of B. That is x1 is equal to, x2 is equal to red. Is that accepted? Yes. Since it is green and it is red and A and B are adjacent vertices, it's accepted. Since the green and red are not same, means adjacent vertices shouldn't have same color. That is your primary motto, right? So it is accepted. Now from B you are going to C. Since you are following DFS in your backtracking. C. Now whenever you are going for C, x3 is equal to red. Is that accepted? No. Since already red has E, you can kill this node here. You can backtrack your solution. Again C. x3 is equal to green. Now you can check out here. Now it is covered with red. Now it is covered with green. Is that accepted? Yes, it is accepted. So it is fine. Now you can go for D here. x4 is equal to red. Is that accepted? Red. Yes. x1 is green, x2 is red, x3 is green, that is C is green, and x4 is red. This is also accepted solution. See. This is also accepted. Fine. Now we can backtrack. We can backtrack. D. x4 is equal to green. Is that accepted? x4, that is, if it is become green, then no adjacent nodes will become green. So it is not accepted. We'll kill this. Now x4 is equal to blue. Is it accepted? Yes, definitely. Why not? B. Green, red, green, then blue. It's accepted. So these are the feasible solutions whenever. No, still we have work. See, you have stopped here at C. Now you can go for B alternative also. Since the solutions with C has stopped, now we'll go for B. Backtrack to here. C. Okay. C. Now x3 is equal to blue. Is that accepted? Green, red, now blue. Yes, it's well known. It's accepted. So you can go for D. x3, x4 is equal to red. It's accepted. No two colors are same. It's fine. Next, D. x4 is equal to green. Suppose it is green, then also it's okay, acceptable. Suppose x4 is equal to blue. If it is blue, then two colors are getting same color, so we can't accept the solution. I hope you are understanding. If not, you can refer my notes for cross checking how you are getting that. Now I'll re-explain this step. You may be little confused here whenever you are doing the complicated step here. First, from A, already we have seen the possibilities when A is colored with red. Now we are checking the possibilities when A is colored with green. When A is colored with green, we have the three possibilities about B. See, B can be colored with red. B can be colored with green. B can be also colored with. So, now since x2 is equal to red only solution we have found, now x2 is equal to red. Now we have one more possibility here. Sorry. You can practice this also. It will be fine. You will get all the possibilities. x2 is equal to green. I think this node will be killed. And x2 is equal to, we can find out x2 is equal to blue. For this also you can find. Otherwise we'll solve now. See, now you have the three possibilities x2 from x2. Since it is backtracking, we'll do the depth first search. Now from B you are getting x2 is equal to red. It's accepted. When you are going to see, if you are coloring with red, it's not accepted, so you'll backtrack. After backtracking, if you are getting correct answer also, you have to backtrack to find the other possible solutions, other feasible solutions. That's what I have done here. Whenever the answer is correct, again you are backtracking and checking other possibilities, that other feasible solutions. Now even here, when x2 is equal to green, it's not, x2 is equal to blue, so you are coloring this with blue. What mean by the possibilities? So again, see, x3 is equal to red. x3 is equal to red. Is that accepted? Yes. Next, you have to go for deep. x4 is equal to red. It's not accepted since it is adjacent node. Next, x4 is equal to green. This is also not accepted. Check once. Since you are coming from green, blue, again if you are keeping green here, it's not possible. So this also will be killed. Next, x4 is equal to blue, green, blue, red, and again blue. It's accepted. Okay, this is all feasible solutions when x1 is equal to green. That is, A is filled with green color. These are the possible solutions you are having. Okay, now from A, B, C, D. This is one. Now we have one more possibility to check. That is x1 is equal to blue. Already we have checked this one. We have checked this one in this step. Now only this is left over. Let's see that also. You can write with me so that it will be a practice for you. Just simply seeing the video will not be any of use. If you are practicing along with me, you can ping me in WhatsApp for my doubts. Then only it will be clear. Root means that at that time no solution is filled. That is empty set. Okay. This is part of the solution. This is not the total solution. Okay. Next. Now we have colored all possibilities. Now only left possibilities. x1 is equal to blue. Now other possibilities. If you are colored with blue, you can color with red. x2 is equal to red. It's fine. Next, now you are coloring with red. x3 is equal to red. If you are writing red here, that's not possible. We'll kill here, and you have to backtrack. Next, C. Okay, now coming to C here, x3 is equal to red. green. Blue, red. Now you are going for green. It's accepted. Now again D. X3, X4 is equal to that. Means D, X4 means here nothing but D. D you are coloring with red. Is that accepted? Yes, definitely. Why not? So this is one solution. Now you should backtrack here. D. X4 is equal to green. If you are making it green, it become adjacent color. So this is not accepted. Next, X4 is equal to blue. This will become blue means it is also not accepted solution. Okay. Now you have to backtrack. How you are going to backtrack? Till where you have to backtrack? C completed, right? C node is completed. C with green is completed. But C with blue we didn't check yet. So C X3 is equal to blue. You can check now. X3 is equal to blue. X3 is equal to blue. Is that correct? Yes. Next, X4 is equal to red. Is that accepted? Yes. This is correct only. X4 is equal to green. If you are writing green here, that is also accepted. So, next last one, X4 is equal to blue. Then will become adjacent. So, this node can be cancelled. This is when B node, we have checked all possibilities. Now, we have one more possibility here. You are having B with X2 is equal to green and B with X2 is equal to blue. B with X2 is equal to blue. See, you can check here. X2 is equal to blue. That is B. It will be killed, right? Since there are adjacent nodes. Now you have to check B with X2 is equal to green. Okay, this you can try in your own notes, and whichever I am providing material for you, in that also it's available. You can check. Otherwise, we'll solve from this step. Then it will be clear for you. Only this step I am solving. When this one completed, don't think this is a step. This one completed this side. X2 is equal to blue, we can't one, green. That means B you have colored with green. Now this is green. This is the step we are doing here. This is green. Okay. Now you have colored with green. Can we go for C with red? C with red. Yes, it's correct only. Next D. D with red. No, since it is adjacent, we can't keep red here. Next, D with green. Green, yes, we can keep. So, this is accepted. Next, D. Here, X4 is equal to blue. Here you can't write blue since it will be adjacent colors will become same. So, these are the possible solution when X3 is equal to R. Now, what you should do? Now, again backtrack it. Now, C is equal to X3 is equal to green. It's not possible. Already you have taken green here. You can't take green here. Okay, it's not possible. So this you can kill directly. Next C. X3 is equal to blue. Yes, it's possible only. Next D. X4 is equal to red. That means we are filling here red. That's also possible. Next, X4 is equal to green. You can keep green also here. It's possible only. Next, X4 is equal to blue. That means you are writing blue here. It's not possible because adjacent colors should not have same one. Okay, these are the possible solutions and feasible solutions you are finding using state space tree from the backtracking method. You have, I'll revise once again the synopsis of this. See, you are having three colors, that is red, green and blue, and what you are doing here, just you are using graph coloring and also backtracking method. Means you have to, till the deepest node you have to go, since you are using DFS, then you should come back to the node after finding the solution, otherwise finding a negative solution. You can't, that is dead end, you can't go further. Then also you'll backtrack. If you are finding one feasible solution, you have to find out the alternative. That's why then also you'll go back. In this way, you are going to find whenever you are having adjacent vertices are same colors, then you can stop your search. If adjacent vertices are not having same color, then you can go till the node D. This is how we expanded the state space tree. For here x1 means you are filling the solution with green, you are filling the solution with red. That is meaning of x1 here. That is solution set. These are the solution sets for one root. That's it. X1 is equal to R. In that also part, then you can find all the possible solutions. You can refer my notes also further. This is about graph coloring using backtracking. Okay, I hope this video will be useful for you. If any doubts, you can ping me in WhatsApp. Thank you.